Hello everyone and welcome to the third Func Prog Sweden this year. The agenda for today, we will have pure functional programming in Dart by Björn Sperber, and then we will have MeetUp programming in Erlang by Max Nordlund. And then in the end I will go through the schedule and the summary of the meetup. First up, I would like to thank our video sponsor, Adabeat. Adabeat is a small consultancy company based in Stockholm, where most of the developers have a background within functional programming. And if you have any questions during the presentation, please use the YouTube chat and we will read them up for the presenters so they can answer them. Also, if you would like to kind of continue and have more functional programming running on YouTube, please also subscribe to our channel so more people can see and view this. With that said, let's start. First presentation, Pure Functional Programming in Dart by Björn Sperber. Welcome, Björn.
Thanks. Thanks, Magnus. Thank you for having me. So I'm Björn Sperber, and I will just start presenting here. And I thought I'd talk to you today about pure functional programming in Dart. And since probably not many of you out there are familiar that much with Dart, I thought I'd also give a brief intro to Dart in general. I am a developer at Soundtrap, which is currently, or nowadays, it's a part of Spotify. And first, I thought I'd talk a bit more about me. So if we look back a couple of years to my previous job, I was working at a company where we were transitioning our core applications to Scala. And in my team, we didn't really have deep functional programming experience, but we were very interested in it. And I had studied functional programming at university, we knew a bit about it, but we haven't applied much of it to commercial applications. So we sort of took it very bit by bit, and we all saw the benefits of immutability. So we started with just modeling our domains as immutable objects. And then it's sort of a slippery slope. So in order to work effectively with immutability, we discovered lenses and found them to be fantastic. And the Scala standard libraries make great use of option and either. So you naturally get acquainted with those, but then you start sort of looking under the hood and discover this topic of monads. And of course you get interested, and then sort of you go from there and discover the state monads and free, stuff like that. But in general, we learned to embrace types. And I'm going to talk very much about the statically typed Haskell-inspired flavor of pure functional programming, but I know there are other flavors, so I hope some of what I'm going to talk about will be applicable, even if you're not sort of sworn to that particular school of functional programming. But also we learned to isolate I/O and the benefits of isolating I/O and pushing it to the borders of your application. And we got better and saw gradual benefits, the more functional techniques we applied, and really felt that this paid off. We got the modularity we were hoping for, composability, testability, most definitely. That was one of our driving factors to get to that promised testability of pure functional code. And in general, we saw beauty in it. So I was very, very happy and sort of wanted to learn more and invested more and more in it, and generally felt that things got better the more functional techniques we applied. So I was really happy with that and in general loving it. But then if we skip ahead a couple of years, I was contacted by an old colleague that I sort of admired a lot and felt like I could learn a lot more from. And he was working on a music project, which turned out to be Soundtrap, which at that point in time was not a part of Spotify. but now is. And Soundtrap makes a free or freemium, easy to use, collaborative digital audio workstation that runs on all major browsers and on most conceivable OSs. If you're even the slightest interested in audio production, music production, podcast production, check it out at soundtrap.com. So there's my little blurb. But yeah, I took the bait. This sounded like too much fun to pass up. And I was sort of voluntarily ripped out of my FP Scala environment and suddenly found myself programming in Dart, because Soundtrap, the core product, the studio, is coded in Dart. And what is Dart? So it's a language that is made by Google. And initially it was intended to complement or maybe even replace JavaScript in the browser. It was supposed to be like natively supported. You're supposed to like just change the language attribute in script tags, and you could code in Dart, and it was fully integrated and had JIT VMs and all that stuff. And there were for a while Dart VMs integrated into Chromium builds, but it didn't pan out, as we all know. While you can still very effectively use Dart to write web applications, the SDK comes with excellent optimizing JavaScript compilers for Dart. Everyone's now given up on the idea that it would ever be natively integrated into browsers. But because Dart was intended to like work in the browser and like support streaming execution and stuff like that, it had some oddities to it. So in Dart 1, like there wasn't a proper static type system, whereas now Dart has been reborn as Dart 2, and it is now mainly promoted as the language of Flutter. And if you haven't heard of Flutter, it is a cross-platform application framework, originally targeting Android and iOS, but now also targeting desktop and web once again. So the circle is complete. If that sounds interesting, check it out on flutter.dev. But this was Dart 2, and Dart 2 sort of shed a lot of the baggage that Dart 1 had, because it was no longer, like it had different motivations. It was no longer intended as a native browser language. So Dart 2 is like much more coherent and less strange than Dart 1. So what does Dart look like? Well, it's intentionally designed to be boring in that it should look familiar if you're already acquainted with other like traditional OOP languages. So if you're used to C++ or Java, you will probably have no problem like reading Dart code. It has some like quirks here and there, but generally most people will find it very familiar. It's got tradition. Oh, right. I am so sorry. I forgot to screen share. I am not sharing my slides, and I will do so now. Terribly sorry about that. So now you see my slides. I hope you didn't miss too much. But yeah, let's get back into it. So Dart supports traditional classes and has a relatively standard inheritance model, supports runtime polymorphism like any like classic OOP language. Compared to, for example, JavaScript, it's got a proper module system built in with nice features such as like language level support and support for deferred loading and other stuff. So it's it's less tacked on than module system you would find in JavaScript, although the end result is similar. Dart also has its own async and concurrency model and language constructs to support that, and standard library abstractions such as future and stream that interact with this async model, which is in general richer and more flexible than the native async model you find in the browser. And it's also relatively coherently implemented across targets that Dart can compile to. It's really, really well designed. It's definitely not like functional programming compliant. It's not properly pure, but it's incredibly useful and works really well for what it was intended to do. And yes, Dart 2 has a proper static type system. It's still a bit of a strange type system, but it's there. In Dart 1, it sort of kind of pretended to be there at some times, but it clearly didn't really have a real static type system. So it supports local type inference, which is nice. You got parametric polymorphism in the forms of generic type parameters for classes, methods, and functions. Like compared to Scala functions, like free floating functions, Dart functions are properly polymorphic, whereas they're monomorphic in Scala, for example. You got your basic type constraints, nothing too fancy. And similar to Scala, again, you can sort of opt out of the static type system and go fully dynamic when you want to. For example, when manipulating JSON structure or something, you can basically ask the static type system to temporarily back off, and then you can call it back when you need it again. It's got the strangest variance rules you can imagine. More of a problem when not doing FP than when doing FP, because it will only really like kill you when you're working with mutable structures, but it's still odd. I think they're trying to fix it, not sure. And just a couple of weeks ago, Dart 2.12 was released and now introduces non-nullable types by default, which you can opt into when you're running in Dart 2.12. And it looks very similar to how Kotlin and to a degree TypeScript does it. But it's great. So now it's fully integrated in all the tooling, static analysis. So you sort of have control over where nullable types and actual null values can propagate through your code. So that's really nice. So how does Dart fare as a functional language? Some parts good and some parts less good. It's definitely not intended to be used like the original language designers and the standard libraries. I mean, they are not they didn't intend it to be used from a pure functional programming perspective, but it's got some things going for it. So we have our immutable references using the final keyword, and it works just as it does in Java, more or less. So nothing fancy there, but it's good to have. And of course, we have first-class functions, which is great when you're doing functional programming. You can treat functions as values, and they're polymorphic in their types, and all that works great. Lexical closures and all. And higher order functions are very, very present. So functions can take functions as arguments and return functions as result values. And a lot of the Dart standard library APIs use higher order functions. So it's very, very normal for Dart code to use higher order functions, although not necessarily in a referentially transparent way. Oh, right, and here I go on about parametric polymorphism again. I like parametric polymorphism, but I maybe mention it once or twice too many now. Okay, let's look at what Dart doesn't do great from a pure functional perspective. So there are no algebraic data types and no pattern matching to support algebraic data types yet. This might change. And there are some nice tools that through code generation do a decent job of simulating ADTs through sealed class hierarchies and generated methods that sort of simulate pattern matching, but it would be nice to have it natively supported in the language. The standard libraries contain absolutely no proper persistent immutable collections, so that's a big downer. And there's no tail call elimination. So if you try to express algorithms recursively, you definitely run the risk of blowing the stack. Right, and here I'm talking about variance control again. Would be nice with variance control, but it's a bonus, I guess. There is no support in the type system for higher candidate types, and if you're familiar with like the standard Haskell type class hierarchies, a lot of them are higher-kinded and they don't express well in Dart. There are some tricks you can do to kind of express them, but you have to choose whether it's like inelegant or slow or properly typed. So yeah, that's a bit of a bummer. And also, as I mentioned earlier, the standard libraries are not purely functional at all, and they are very voidy and will throw exceptions in your face at the slightest provocation. So here I was in Dart and had just left sort of a very FP world, and I had a lot of fun. I loved the product and I loved coding in it, and really enjoyed programming in Dart. It was, it's generally a really nice language to program in, but I was definitely missing the FP parts, and I think I was maybe a bit damaged by FP, because I did have problem viewing non-FP code as beautiful, and I missed the beauty of pure FP properly applied. And I had also grown very used to basically nothing being mutable, and now I was surrounded by mutable fields and collections, and suddenly had to start reasoning globally again, which I'd sort of learned that, okay, I don't need to do that anymore, and things just got like more difficult to do, and you had to think about more things, and it wasn't as straightforward. And I also missed, for example, ADTs and pattern matching, and a lot of like functional techniques sort of replace some of the standard like OOP patterns with more elegant functionality, I believe, at least. So it felt very weird to, like, instead of doing a pattern match over a nice sealed ADT, felt super strange to do the visitor pattern for example, which just looks very clumsy in comparison, I think. Very subjective. Oh, and then there's null. I was not happy to get reacquainted with null. I had learned to express partiality and failures through option and either and other things that are visible in the type system. And at least before Dart 2.12, nullability is not visible in the type system, and it can attack you at any point. So that scared me. Oh, and exceptions. Exceptions are great for truly exceptional cases, I believe, but at least the Dart standard libraries maybe overuse them a bit, and as we all know, that kills referential transparency, and Dart also has the flavor of exceptions that, once again, are not visible in type signatures. So once again, you have to be very, very defensive, which I didn't used to be when working with option and either and stuff like that. And once again, I had to apply global reasoning where it felt like I should get by with local reasoning. And right, yeah, sure, uncontrolled side effects. Once again, I keep repeating myself, but I had gotten used to testability more or less coming as a bonus feature of just applying pure functional design. And now I had to think about it again and use some of the sometimes unwieldy techniques used in traditional OOP in order to write testable code. So that was a bit of a bummer as well. So what I started doing was start writing a library for Dart, for functional programming in Dart. And I'm not sure how it should be pronounced. I haven't really decided, or I don't really have a strong opinion. I'm gonna call it Dart Z in this presentation, but yeah, I could change my mind. And I definitely borrowed heavily from Scala Z and its spiritual successor cats, Clojure and Haskell, and sort of tried to make something that would feel familiar if you come from those environments. So I started with just implementing option and either because I missed them and I needed them for the next step, which was to write some basic immutable collections, because I really missed those. And I really missed like proper immutable collections that are persistent, structure sharing, efficient when applying functional techniques on them. And then I did shoehorn in some encodings of fundamental Haskell type classes. So if you're into that kind of FP, you've got your monoids and your functors and your monads. They're not expressed sort of in as useful a way as you're probably familiar with them from Scala and Haskell, but they are still useful, and they clarify intent, if nothing else. But since Dart lacks higher kind of types, you can't sort of use them as freely as you would in languages that do. Right, I need more stuff as well. I always need more stuff. So I needed a state monad, I needed lenses, of course, I needed tuples, lots of them. And once again, because Dart 2, at least, it's very hard to simulate higher kind of types, then monad transformer stacking becomes very clumsy. So I've actually instead opted of hard coding a couple of generally useful monad stacks. And the most powerful is called evaluation, and it consists of like the monad stack that I often ended up with in Scala. So there's reader, writer, state, either, and asynchronicity support wrapped into one. It is clumsy, I'm aware of that, but it's a compromise just to get a decent encoding that is easy to work with and fully safely typed in Dart at the moment. Free monad, I needed a free monad. And if you're familiar with the coordinate trick, the implementation in Dart said uses the coordinate trick to make it sort of the freer flavor, meaning that we don't need to supply a functor for any type constructor that we lift into free. So you can lift any type constructor into free. There is also a pure functional streaming module in there. It works, but it's still like, it should have a nicer API and it's still considered experimental. And of course, there's also bridge code in order to integrate all this with the built-in Dart types and the standard library thing. So stuff to like convert between Dart mutable lists and immutable lists and maps and stuff like that. And also type class instances for a lot of the built-in types. So there are monoids for integers and strings and lists and stuff like that. And a lot of other stuff. So I thought I'd quickly just blast through the collections that are available in Dart Z. So there's first iList, which is very, very similar to standard closure lists and also standard Scala immutable lists. So just like those structure, it's a standard singly linked cons list and has very, very similar time complexity. So cons head and tail, big O1 complexity, and traversals are efficient, but random access isn't. So if you need random access, there is iVector, which once again is very similar to closure vectors and also Scala's immutable vectors. And they give you better time complexity for random access and updates, and a couple of other things that iList is not good at. Then there is IMAP, which is an immutable map. And it is implemented using self-balancing sorted trees, and therefore has efficient lookups and updates by key. And since it's sorted, it's also got efficient minimum, maximum, least upper bound, and greatest lower bound operations, as well as ranged folds that are very, very efficient. So besides being a generally useful map structure, it's usually deals with timeline-like structures, timeline-like data well, especially where you want to do like windowing and sort of look at time intervals or similar things that are sort of sequentially but sparse. Oh, right, and there's also iSet, and that is essentially an IMAP of something to bool, and it behaves just like it. But it's a fully functioning and reasonably efficient immutable persistent set. And then there's some specialized structures on top of this, but I just thought I'd quickly go through the most important ones. And yeah, let's do some live coding. I will pop over to some code. So what I've got prepared here is just something to maybe get you acquainted with Dart in general, just to see like, okay, this is how Dart looks like, and also look at how some of the immutable structure in Dart Z look like, and maybe some of the benefits of sort of applying Haskell-like type classes on top of this, and see how we can do Haskell-like collection transformations. All right, the first line here. This is where we import our library, and this is probably the best reason why it shouldn't be pronounced Dart Z, because if it's pronounced Dartsy, then it reads Dartsy, Dartsy, Dart, which is hilarious. So yeah, let's look at this. What have we got here? So we got a map structure that is keyed by strings and has list of string values. And in practice, it sort of associates lists of ingredients to names of dishes. So we got our caprese salad, which consists of tomato, mozzarella, basil, salt, and olive oil. And then we got some other dishes. And it's, yeah, this is just an example. This will be a very, very boring bolognese. There should at least be onions in there and probably more spices. But yeah, hopefully you get it. And then we got two other values defined here. So we got menu for 2, which starts with a caprese salad and then continues with a pasta bolognese. And that's a pretty heavy dish, so we don't need dessert there. And then when we're alone and don't need to impress anyone, we just eat mac and cheese and stuff ourselves full of Oreos after that. So what I was thinking was that we could try to write a function that, given a menu and maybe also the number of people that we'll be eating, we could try to produce a shopping list to tell us what we need to buy to prepare that menu for a specific amount of people. So we could then start with saying that the return value should be mapping between name of ingredient to the number of units of that ingredient that we're gonna need to buy. You see here already that like my example is falling apart, but bear with me. It's just an example. Let's call this this function build shopping list, and it needs to base its decision on a menu, which in practice are lists of string, and let's call that a menu. And then we also need to know how many are going to be eating. I want to type number of eaters, but that seems, let's just call it number of people. Something like this, and just to temporarily make the type system happy so I don't have red all over, I'll just end with an exception. I will remove this later, of course. So let's look at this. So already from this menu for 1, we realize that, since we have this kind of silly data modeling where the dishes are represented just by strings, then there's of course no guarantee that we'll be able to actually produce a shopping list for any given menu. For example, not the one containing mac and cheese, because we actually don't know what ingredients go into mac and cheese. It's probably macs and cheeses or something. But okay, this can clearly fail. So what should we do then? Could return null, or an empty map, or a partially filled map, or maybe throw an exception or something. But no, we will not do that. We will wrap the return type in option. And now it's hopefully visible for anyone trying to use this function that, okay, clearly this function can fail somehow. So we capture that in the type system. So that's a good start. And then the next step would be probably to just grab all the ingredients. At some point, we need to figure out what all the ingredients are so we can reduce it into a shopping list. So let's start with declaring a variable for that, and we probably need to do something with menu. Menu is of type ilist. Let's look at what ilist is. Okay, so ilist is a traversable monad plus. So that's a good hint. It's something we can traverse over. So if you're familiar with traversable types in Haskell, it's sort of operating functions are usually called something with traverse. And we actually know that these traversals can fail. So, okay, traversing with option as applicative effect sounds good. And once again, since this is Dart, which doesn't properly support like type classes, like the different variations of traversals are hard-coded in here, which is sad, but it makes it slightly easier to choose now. And looking at these, we probably want a monadic traversal as well, because we want all the ingredients at the end in one chunk. So let's choose a monadic traversal with option as applicative effect. So here we get to pass in a function, and we get served with dishes. So we're traversing our menu, which is a list of dishes to prepare. And here we can just look up ingredients by dish. And it just so happens that this bracket operator on IMAP, since this is a Dart-Z map, it will do its best not to return null or throw exceptions in your face. So this will actually already return an option for us, which satisfies the contract of traverse option n and is exactly what we want. And we can make this more explicit by using the get method. The brackets, the square brackets are just syntactic sugar for get, and the type of get here returns an option of ilist of string, because IMAP can't guarantee that it has a mapping for every given key you give it. And now we actually see that we can replace this with a method reference to make it even tidier. So that's great. So now we have our ingredients, which is an option of ilist of string containing all the ingredients for all the dishes in the menu. And now we somehow need to transform that into a shopping list. And it's sort of a reduction aggregation kind of thing. So once again, we remember that ilist was a traversable structure. Traversable structures are always foldable functors. So we know that this must have fold operations on it. So let's try and declare. Oh, right, sorry, I just need to backtrace. Right, so since this is an option of ilist of string, we might already have failed here. So maybe I'll just temporarily rename this to maybe ingredients, because this is actually an option of ingredients. And options are functors, so we can map over them. So let's do final maybe shopping list equals maybe ingredients dot map. And here we get to supply a function that does some transformation of the ingredient list if it exists. So here we have the actual ingredients. And now we want to somehow transform these into a map that counts the number of ingredients that we need to buy. And as we mentioned earlier, ilist is a foldable structure, so there are plenty of folds on it. And in this case, it might be very, very convenient to use monoidal folds through fold map. So let's try that. So fold map wants us to supply a monoid to reduce some kind of transformation that we do here. So let's, and here we get to transform every ingredient in this list to something. And let's transform it to a singleton map, where the key is the actual name of the ingredient itself. And then we need to figure out, like, okay, at this stage, how many of this ingredient do we think we need to buy? We actually don't know that yet, because that's sort of a global truth. But for now, all we know okay, we encountered an ingredient, we need to buy at least enough to feed number of people. So just put number of people in there. So now we have a neat transformation where we transform every ingredient into a singleton map. Now we just need to merge these into one map. So let's do just that. So there is a pre-prepared IMAP monoid that comes with .z. And since maps have unique keys, like there's at most one binding between each key and some value, we can't have duplicate keys. IMAP monoid needs to know how to handle the cases where it's being asked to merge multiple maps into a single one. It needs to know, okay, what do I do if I encounter key collisions? And that's why you need to also pass a monoid to IMAP monoid that basically defines a strategy for how to deal with collisions. And in this case, we know that we actually just need to sum them up. And there's, of course, a pre-prepared int summation monoid, which is called intsum mi for some reason. And this is actually all we need to do, I think. So now we can actually just return this, and hopefully everything types. Yes, it types. So let's try it out. Build shopping list for menu for 2, maybe. And of course, that's going to be 2 people who are reading that. So let's run it and see what we get. And this is slightly smaller. Okay, we get something reasonable here. So we get a sum, meaning like a filled option. We did not fail. And that carries an immutable map that says, okay, we need to buy 2 units of basil, but we need to buy 4 units of olive oil because olive oil is needed for both the caprese salad and for the pasta bolognese. But we only need 2 units of tagliatelle because we're only 2 people eating, but we need a lot of salt and tomato because it's delicious Italian food. And similarly, if we try to build a shopping list for menu for 1, which it's only 1 person eating, and run that, then we, of course, just get none back because we were never able to figure out what ingredients are necessary for cooking mac and cheese. So that's a small intro. I hope it made some kind of sense. And I'm just going to pop back to my presentation. So thank you very much for listening. I hope parts of it, at least, were interesting. And here are some links for you. So here is Dart-Z on GitHub. If you think Dart sounds interesting, check it out on dart.dev. If you think Flutter sounds interesting, check it out on flutter.dev. And if you think Soundtrap sounds interesting, check it out at soundtrap.com. Thank you very much, and over to you, Magnus.
Thank you very much, Björn. Thank you. You get an applause here from me in the studio. I have one question. What's the best way to get started with Dart and Dart-Z?
Right. So I would really recommend actually starting with Flutter if you're starting with Dart from scratch.
Yeah.
It's got a really nice and tight development environment, and lots and lots of tutorial projects, very nice tutorial projects on Flutter.dev, and lectures in sort of how to stepwise go to more advanced levels. And for Dart-Z, it's horribly poorly documented, but there are an examples directory on GitHub that will show you how to solve some problems using Dart-Z, using pure functional techniques. So there is that would be one way of starting that. There is also a series of tutorials from Resocoder. I don't know if you're familiar, at resocoder.com, where he uses and explains several Dart-Z types and uses them in sort of real Flutter tutorials. So that's also a good place to start.
Mm. And assume you're super interested in starting to work at Soundtrap. can you do it without being a Dart or Dart Z coder?
You can definitely do that.
Yeah.
I don't think we've ever hired someone who was already like a seasoned Dart coder, because not that many exist. And we generally find that people are up and running in Dart in days, assuming they already know a couple of languages and know the web.
Yep.
So it's definitely not a prerequisite, but it's good if you are interested in learning new languages.
Yes. Let's see if we get more questions. No, I have one more question. What more? Do you know any more companies in Sweden that works with Dart?
So yeah, Flutter is actually used by a couple, but no, I failed to actually come up with some Swedish ones right now. I know there are some Flutter companies in
Do you know
Stockholm.
any other like international companies that works with Dart?
Yeah, Workiva, for example, work with Dart. Google, like Google AdWords, the interface there is written in Dart, and several Google applications. I mean, this is Google. They develop the language. But for example, I think some of the Google productivity apps, I think maybe Google Home might be written in Dart by now and in Flutter.
So,
Don't like quote me on that though. I'm not 100% sure.
So if you want to make a career in Google, Dart could be it. Or if you want to make a career in Soundtrap, go for Dart.
They're investing quite heavily in it, so definitely.
Cool. Again, thank you very much, Björn, for your presentation.
Thank you for having me.
You're welcome, most welcome. Thank you. Then we'll go over to our next presentation, MeetUp Programming in Erlang by Max Nordlund.
Hello!
Welcome again, Max. And this time you're not doing JavaScript, you're doing proper programming. Haha, haha.
I saw what you did there about the module system. That's all I'm going to do.
So, we're going to hand over this one.
Yes.
And we hope it works, as it did when we tried.
Moment of truth here.
We'll see if it works, and Björn or Max gets up and running. Ta-da.
Lovely. Hello. So I have no fancy presentation. I'm only going to do live coding. And I hope you will give me many, many, many questions. So this becomes an interactive session and not just like me having a monologue. So meta programming in Erlang. Well, let me start by talking a bit about meta programming in C. In C, you have a preprocessor. It works at the text level, which means that it substitutes A for B, and it's very simple. This means that you can do all sorts of craziness, like substitute an opening parenthesis, and it will be fine. You can substitute an opening quote to automatically turn stuff into strings or whatever. This is very cool, very nice, but it also comes with some caveats, like accidentally quoting just parts of a string or like the rest of your source code. And that is why the Erlang preprocessor actually is based on the token level. So I'm gonna do this. Let's see. Do we have no? Yeah. Here's an example of an extremely small token-based macro. It's called define. In this case, we call it in, and this is what it outputs. It outputs and Merlin in transform, calling some function in, and then ends with another and. And this is a very strange one, so I can write something more simple and probably useful. Maybe you just need some constant, foo, 1, 2, 3. This is pretty common if you have, magical numbers in your code. You could also do a logging macro, for example. Maybe you have some format and args format args. Of course, that's not very useful. So you can maybe you want to add the name of and line of the file first. You would do it like this, and you would do something like s:" p space. And here's a cool thing: if you have this is valid Erlang syntax, and what does it do? You might ask. Well, I'm glad you did. It joins strings. So if you have multiple string literals next to each other like this, you only separated by the white space, they actually get combined. That means that its format here is string constant. It will be fine. You would call log above like this. Maybe I have my message, something like this. And this will be expanded to IO format s:"p space my message pn file line. Of course, this is kind of obnoxious way of writing a list literal, but it works. File and line are magical built-in macros, and they expand to the current file and line. So this, for example, would probably be something like maybe include /marlin.marlin in .horl or something like that, and the line would be maybe, what was it, 19, something like this. Okay? Very nice, you say. Yes, it is, until it isn't. What's the problem with this? Well, it turns out that if you have a macro that is either based on text or, in this case, on tokens, it's not hygienic. And what do I mean about hygienics? It means that variables defined inside a macro gets renamed so they don't interfere with the surrounding code or other macro invocations. What do I mean by that? I'm just going to go into the Merlin. This is like a sneak peek, by the way, but I thought it was fun. I needed some example code. So if I have a macro that defines some variable, for example, maybe I want to do maybe some sort of a search on expectation. So I expect A to equal B, for example. I could do A equal B. This is fine, right? Whatever you put inside here, whatever tokens you put in this space will be put here, right? So when you call this expect 1, 2, that becomes 1 equals 2, or match 1 to 2, which will fail. However, if you use some sort of expression like file, it will become file equals 2. But if you do some other expression like file Erlang, like that, or something like that, that would become, see where this is going, right? It's a pure substitution. There's nothing fancy going on. And this means that if you have something that introduces a variable, that would cause problems. So instead of having A here, maybe have foo equals B. And since foo is not part of something here, maybe have A plus B, so I actually use it. All sorts of fun stuff will happen. I'm going to go back to that. That becomes foo equals 1 plus 2. which means that if you do expect, I don't know, 3 plus 3 or 4, you get, and, sorry, like that. And what will happen is that this one will work. It will assign the value 3, 1 plus 2, to foo. But this one will fail because 3 is not equal to 7. This will be a bad match because you do pattern matching on bound variables. Right? If you were to do this in Elixir, this would work because then this will be, it will be silent to relim. So this is actually like this. In Elixir, this would happen. They're all numbered, so you don't actually, and then you use the pin operator, the hat in Swedish. Yeah, the hat operator, like that. Anyway, this is of course sad. We don't like this. Hygiene is nice. It's nice to, folks, keep your hygiene. It's good for you, right? But we can't do that. So what do we do? Well, we can take a look at how the actual assert macro from the standard library looks. So let me include it. Include lib stand lib include. Is it? Is it not? That was not good. Let me restart my language server and see if it becomes less sad. Yeah, this is how I restarted, by the way. Just kill it. It will, that will happen, and then it will be fine again. So, see, it's all good now. Okay, let's try that again. Okay, like that. This is what the assert macro does. It does a bunch of like no assert debug stuff, so you can turn it on and off. If you ignore that and look at the actual defined assert, it looks like this. This is a more of an interesting macro, right? Okay, what does it do? It does begin, end, okay. And then it has some function expression, fun expression, that it immediately invokes, also wrapped in an additional parenthesis. This looks weird. Of course, unless you come from JavaScript, because then you will immediately see that this is an immediately evoked function expression, which has been used for ages in order to give you a new variable scope. So back in the day, when you included a script tag, or when you do include a script tag, every time you wrote var, my var equals something, it will be added to the global scope, which is sad. So you wrap it in a function, because function has there's function scope in Erlang and in JavaScript. And then all the variables gets contained. But there's a catch. If you substitute this directly, like if you go back here, if you start to substitute something like this, you would end up with something like looks like this. Fun. It does something. And right, and then you invoke it like this. However, if this gets substituted in the wrong way, then suddenly you might do this, and you try to invoke whatever this happened to return. And this is why the assert macro in Erlang, in OTP, uses begin end, because that prevents this issue. If you have end here, and you have begin like this, this will be invalid syntax, and you will get a syntax error, a compile time error directly, right? You won't get a weird runtime error. Great. But why does it need a new variable scope? Hygiene, right? So what it does, let's make this big again. So what it does is it creates a new variable scope. This is called sheep source of truth, and for the longest time was like, why are they not just writing true? Because the compiler is actually smart enough to realize if a pattern can never be matched if you only have literals. So again, whoops. if you have a case that looks like this, true of true, you would get a compile time error for here because false can never be matched. It can see that this will always match here, okay? And it will try to say that to you and say, hey, whoa, what's up, what you doing? And when you do assertions, you usually have, in test, you usually have like example data, right? So you would have an actual literal that you want to match to something. And if that happens to be too easy to figure out that it's wrong, you get that compile time error and your test won't actually run, but you get an error instead. This way, since the compiler is not smart enough to figure out that process alive self always returns true, you can do it like this and like trick the compiler to actually run the code. So you actually get a test error and not some random compile time error somewhere, which also looks weird because it's like in the middle of some macro expansion. And it just checks if it's okay or if it's not, and then it throws an assertion error, blah, 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 blah. Right? So let's go back to this. What happens if I define __t outside when I use assert? Kids, don't actually do this, please. It would make poor assert sad, but let's do it anyway. T equals false. Assert 12 equal 34. This will explode with a bad match. Whoops. Oh, yelp. Okay, sure. Here. Because T is already bound to the value false. And even though these variables or bindings doesn't leak to the outside scope still leaks into a fun, right? Because it's a closure. And this is how you are able to refer to variables in the surrounding scope, right? Which is what you want with a fun usually. You do a map and you want to refer to a variable like an argument to do something or whatever. Very sad. Much sadness. So how do we solve this? Parse transform. The ultimate tool, the ultimate foot gun, also known as compiler plugins. Okay, so in Elixir, you get hygienic macros. You can break hygiene in a very specific way. You have the quote-unquote macros, built-in macros. You have all this nice stuff. We don't get that in Erlang, but we have parse transforms instead, which is way more powerful because you can literally transform anything to anything. It runs a function on the AST, the abstract syntax tree, on every module, right? Or every module that enables this parse transform. And if you put this in a global include, or if you put this in a global compile time option, you can run it on actually every module that you compile. Which is great, because that means you can do all sorts of fun stuff. For example, hygienic macros, so you can generate unique variable names that doesn't, because you can look at what variables are already defined and stuff like that, right? Of course, this is an excellent way of making spooky action at a distance. You know, you write this code, but no, I will inject this completely other code. Haha, right? The current largest use of this in production today in Erlang is in Riak. Or actually, it's from Basho, who wrote Riak before they went bankrupt. And that's called Logger. Logger is a logging library. I'm not going to go into exactly what it does, but you can read on the transforms on their README, I think. The gist is that you can disable certain logging levels at compile time if you wish to. So you can say, hey, logger, I want to turn off everything compile time from info and below. And what happens is that it runs the parse transform on all your code, it will find all logger, :info, or whatever, right? All the logging calls, and then remove them, which is great, because then you don't pay anything for that, right? You can also have a macro that would do like case, should I actually log this info level? True, yes, do the logging. False, actually do nothing, right? That would be a dynamic check. And this is something that the logger, the built-in logging library does. Both are valid. And this is an example for why you would like to run a parse transform on every single module, because you have login statement everywhere. Okay, enough talk. Talking is boring. Let's talk about parse transform. So parse transforms are cool. You get the forms, you get the compile options, you do stuff. It's great. Except it isn't, because the forms are a list of tuples, where the tuples look differently depending on the form, on the syntax. Right? In Elixir, the syntax is much like the syntax nodes are much more uniform, which means that you can pattern match them more easily, you can generalize more easily. They are of variable length tuples, which means that they are kind of obnoxious to handle. All of them have two things in common. The first is the name, like function, operator, stuff like that. Case, if. The second is the location, so line number, sometimes line number and column number, sometimes line number, column number, file, stuff like that. And then there's stuff. Some, like nil, which is this, for everyone who's not familiar with the internals. The empty list is actually nil, right? The start of every list is nil, and then you have cons all the way up. Nil doesn't have anything, because again, it doesn't contain anything, right? So it's just a two-tuple. Others, like function, contains, let's see, it's the name of the function, the RT, the arguments are like the cases, and each case contains like the argument part here. It contains if it has a guard, and then it contains the actual function body, a bunch of stuff. Right? So most people use a library. The most popular library is called parsetrans. I think it's the one Ulogger uses, I'm not sure. It's pretty great if you want to do simple transforms. It does some trickery using tuple to list and list to tuple, which means that that's how it generalizes on all of these forms, which means it's also future-proof. And the ways you do it is that you, kind of like Merlin, which I'm going to show later, you send in your function and the forms, and it just runs it on everything. And as long as the transformer ends in something continue, it will just continue, and it's fine, right? And then you can return stuff like stop and return, like stop execution at this point. And this means that you don't need to write a manual visitor pattern matching on all known syntax trees, right? Okay. But if you want to carry some state with you, say, I don't know, the currently bound variable names, so that you can generate a new unique one and doesn't mess up the scope, right? Then you're out of luck. I think there's actually an implementation for this in parsetrans, but it was not documented, and it's a really long signature, and I had no clue how it worked. But it's used by some other examples that they have. So I wrote my own. This one also tries to use more of the standard library. So in the meantime, from when parsetrans was written, stuff has happened. One thing is something called MERL, which stands for Metaprogramming in Erlang, which is now part of the standard library since many years back. That is what does this. I have extended it a bit, but the idea is that you have a macro. This parses all of this lovely syntax, and then you have some special stuff like have an underscore in order to be able to pattern match on syntax trees. So you don't actually have to write the syntax tree by hand here. You can write in Erlang syntax, it will parse it and replace all of this with an actual like syntax tree to pattern match on. It's actually a bit more complicated than that, but it works. It's great. What I have done is I have the QQ. It's just like this in vanilla Merl. What I've added is that the ability to do it in function clauses like this, because you can't do that in vanilla. Implementation details, but that's just a thing. Anyway, so what I did was I wrote a library that allows you to do a transform while carrying some sort of state. And this is really nice. And for those who are observant, / really into function programming, you would see that this is actually a map fold, right? You do a map producing a new list while carrying a state, a fold over all this, right? But it's a deep map fold because I do it over recursion instruction. And in order for you to be able to splice in multiple node syntax node or remove one, it's actually also flattens as it walks through. So it's a deep, flat map fold, kind of. A lot, but in practice, it's really nice. You would use this Merlin quote to get these nice things. You do some pattern matching on the syntax tree. You can choose which phase, because maybe you want to do it on while you do the visiting inwards, or on exit, right? Enter or exit. So you can choose that. This is really nice for cleaning up state, for example, on where you go exit, and then on enter is that you do something new. Not in this transform, but in other transforms, I have done it so that I would get all the variable names in this function, so I can generate new ones. I do that on the enter on the function, and then below is where I actually look for some, I don't know, maybe the logger info call or something like that, and do something clever with that. But then I have all of that, and when I do exit on the function, I can clear all the variables, right? Because they are not relevant anymore until they come to the next function. Stuff like that. Errors are obnoxious. You need to return a very special form in order for that to work. You can just return error. It's great. I think you can do this in parse trans as well. I'm not sure, since I don't use it. But it makes it much, much easier to use, right? This is make it nice. And it builds on Erlang syntax, which is a library from the standard library that allows you to do stuff like copy position. And this figures out how to do this. Set position, right? Yeah. And it figures out how to get the position, even if it's an error. Like this is how it's actually done. It has like this error, and then the position is hidden inside something, and just obnoxious. So using the functions, the wrapper function from Erlang syntax makes it much more foolproof. And this is basically what this does. It uses Merl, and it uses Erlang syntax and Erlang syntax lib to implement what parse trans does using a fancy tuple to list to tuple trick. Get position, and you do stuff, and I do some parsing in this case, and here I generate some new code like that, splicing in needle, high, low. Yeah, do some comparing. Yeah. Then how does this look like? Well, I'm glad you asked. I wonder how many times I can do that. You know what's great about not having anyone here? Nobody can stop me from doing really terrible puns. Maybe. Okay, I have 2 people here. They might stop me. We would see. Anyway, so I've defined a macro called in to implement the in operator as you would find in other languages. In Elixir, strongly inspired by Elixir, this allows you to write code like foo bar when foo in comma B, comma C. You basically want to do this because writing it, whoops, sorry, whoops, foo. Like when you would write this in vanilla Erlang, you would have to do this. Whoops, sorry. Man, I'm terrible tonight. Bar equals A, or else. Bar equals B, or else. Bar equals C, right? This is what the inner operator actually expands to, right? Nothing more. But the normal macro can't do that. This is too advanced. You can only substitute tokens. So what I do, if we go back to the beginning, if you remember, I change it to this. So what actually happens here is that this gets, the question mark in gets replaced with this thing. Then I find this in my parse transform and turn it into this. Kind of funky, but it's nice. Let's see if I can remove all of this like that. This is an example. Let's see if I can find. I should have it. Example here. In example here. Yeah. So you can ask the compiler to run all the parse transform and then print out the source code so you can see what it looks like using the dash uppercase E option. And this is, then you get a .e file. This is what I've done on the example above here. And what it looks like is this. You get some file, module, compile time, stuff, blah, blah, blah. And then you can see what actually happens here, right? This here, maybe greeting in hello, 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 okay? Becomes when maybe greeting equals or else, just like you would here. Actually, it's in the reverse order, I guess, because I'm using some sort of list reverse thing that usually happens when you do a map by hand. And then you have this where I use a range instead that uses the dot operator because I wanted to see if I could do that. And it gets this and also in less than 10. This is stuff you can do. You can do more advanced stuff as well. Let's see if I can maybe see the with statement example. You can also implement cool stuff like the with statement from Elixir, because I like Elixir. With stuff, do some pattern matching. Here I have something that looks a bit like a monad, right? Of course, there's not actually the syntax in Erlang, right? So I had to cheat a bit. This syntax comes from list comprehension. So you do this list comprehension that looks funky up here, and then I can transform this into something useful. So if you look at the complex examples, maybe even easier to see what it does. It does one arrow here, it does another arrow here. Here it also checks a when, a guard expression of, and here I map on the success cases, else here I match on the error cases. So in case, for example, status is not less than 300, for example, 404, I match on that. That would come from here, for example, right? And then, of course, this has to be dejoggered somehow, so it becomes, let's see, complex. It becomes this lovely nested case of cases of doom here. And here you can see also my secret variables which I have generated 1, 2, 3, 1, 6, 8, stuff like that. Of course, this is not code you would like to write, but it's correct. Like it does what you want it to do, semantically, at least. And it wraps it in OK error, which means that I can combine all the pattern matching down here, and you just wrap it / prefix it with OK error in order for you to be able to match on both. And this many is even, oh, this is glorious. Just look at this beauty. This is the stuff you want to avoid by writing it more like this. This flat, lovely code. So good. And I've seen this in like real code at work, this huge nesting, which, because we don't have with statement, we can't unnest. Okay. Maybe I should start with questions. Are there any questions?
No, not any questions.
No questions.
People are all onto you. They totally understand you. They want more of your fun jokes.
Oh, lovely. I've documented a lot of this in edoc, by the way. So I didn't show you that, but if you actually go to Merlin here, like most, if not all of the functions, at least the public ones, should be, let's see. Yeah. So here's some documentation. Oops. Here's some more documentation that try to explain what this does. Yeah. Reverse shell. Can I start a shell? The macro, the Q macro, you can actually call it in the terminal and see what the syntax looks like. So if you have a tuple that looks like this is what it actually looks like in what the inside looks like. And in this case, they're all going to be 1 because it's going to be on line 1. It defaults to that. But you see here the tuple. The first is an atom, and then it's a variable called foo. See here. Case foo of, okay, and like that, you get a case instead. It looks like this. This is really good, and it's really powerful and really nice. Of course, we don't have variable expansion in the shell, so I can't show you this using the actual syntax like this. But the Q here, this is the same as this. It also adds the line, so it can give better error reporting, but otherwise it's the same. Yeah. I think I'm good then. If there's no questions? Really? You got all that fast?
They should all start working at Kivra. They all know this stuff already.
Yes. No, seriously though, it's really fun at Kivra. We have an awesome time, a lot of Erlang. It's lovely, and some Python.
Yeah, I'm going to ask the same question to you. Do you need to know any Erlang before starting at Kivra? Or will you learn all the Erlang?
Yes. Most people actually haven't written Erlang before they start. Most have come from Java. And so we do not expect you to be up and running for, a couple of weeks.
Yeah.
If you get fast on that, great. If it doesn't, it's fine. It's okay. Erlang is nicer than Scala though, because it's much easier to understand because it's strictly evaluated from top to bottom. It's dirty, it feels more imperative.
It does. I can kind of agree with you there, actually.
Yeah.
I have another question, Max.
Yes.
This is your second time you're speaking or presenting.
Yes.
How is it to present?
Fun. It's a bit weird when it's completely quiet and only 2 people here. It's much easier when you have an actual crowd, but it's fun. It's so nice. And you can, of course, just do some live coding like this, or you can make a nice presentation, or have very silly animation as I did last time.
We love that. Yes. Have people offered you free coffee at the job now, after presenting? Or has some bad stuff happened to you?
I work from home because of the pandemic, so I haven't even been to the office.
Yeah, so you're waiting for that? People coming up to you. That was like the best presentation or the worst presentation?
I know that my boss, she saw this and she liked that I showed this.
So you did something right at least.
Yes. I did.
Good. Then I'm going to ask the same question to Björn. So how was it to present? Was it good? Would you recommend others to present?
Definitely. No, but it was fun. And once again, sorry for forgetting to present my deck from the beginning. I will not make that mistake twice. No, but it was really fun. And good way of sort of getting more savvy at presenting. So it's great.
Yeah.
Thank you very much. With that, I'm going to end. I don't know if my slide shows or not. I have an issue with my laptop. Anyway, we have 2 more meetups coming up in the spring. One is in the 4th meetup will be in April 28th, and then we have the 5th meetup in May, 25th of May. Then I'm looking at a meetup in June, also depends, but in June people seem to be very busy all the time, so we'll see. It's also very dependent on that we find speakers or people that actually wants to present. So that's why I really like that you said it's no dangerous, no hassle to speak. It's really fun to present here. Yeah. With that said, I don't have anything more. Do you have anything more, Max? No? Björn, do you want to add something?
I'm good, thank you.
You're good. Thank you. Then again, I want to give an applause for the presenters. Thank you very much for coming and presenting. This would be nothing without anyone presenting, so thank you very much. With that said, have a nice evening, everyone, and see you next time. Bye.
Bye.